In this video, I'll be going over the 5 different levels to building cram cannons. I'll start with the beginner ways and then end up with the highly optimized 3D cram. Now I'll start with level 0. I call this the Clueless level. This might be something that someone brand new to crams might do, especially if they're used to building other systems like APSs. They might fill the entire bottom with some kind of connection layer. This is fairly common when building APSs. And in the middle, they might have a turret neck like this. And then they place their packers and shells, kind of like autoloaders in APSs. Then they might copy paste the whole thing to get to the final size. Now we'll add the firing piece and some gauge increasers. The stats on this are absolutely horrendous. 20 firepower, 2,000 materials per firepower. Now we move on to level 1, 2D crams. Now one of the most important steps to building the cram cannon is optimizing your pellet usage. Pellets are extremely expensive, they cost way more than any other blocks, and you want to use as little of them as possible. We want to maximize usage of every pellet by surrounding them with as many packers as we can. We can do this by tetrising the packers and the pellets. To do the Tetris, you'll start with a 6-way connector, then grab a packer. If you look at the packers, they'll have pins and they'll have cups. You want to make sure that the pins are aligned horizontally like this. None of them are on top or on the bottom. Then connect the cup in the back to your 6-way connector. Cups will connect to connectors and the pins will connect to pellets. Then you'll grab your prefab tool and copy the pattern like this. You want to go 2 blocks in one direction and then 2 blocks in another direction in order to maintain the Tetris pattern. Something like this. I'm going to go right 2 blocks and then go up 2 blocks. And then go down 2 blocks, right 2 blocks, left 2 blocks, down 2 blocks. And then repeat until you run out of space. Once you're out of room to place your connector, you'll switch to pellets and fill in the gaps. Now there's some empty spaces where I purposely didn't put pellets. That's because they don't have connections to any packers. How this Tetris works is if you look at a particular pellet like this one, it's surrounded on all 4 sides by packers. This is the most efficient way to surround every pellet with as many packers as possible. Now we just copy paste to get to the size we want. Then on top, you'll just connect all of these connectors together. Now we add gauge increasers. If we look at the stats are better than the previous attempt, but there's ways we can significantly improve this cannon. Now we're on to level 2, basic 3D Tetris. For 3D Tetris, the first layer is identical to the first one. You just have the same packer Tetris and then the pellets in between them. I just copy pasted what we had earlier. Now we're going to make this 3D. You want to find where all the connectors are and then place another connector on top of them. Next, we'll expand our connectors like this. Just a note, if you happen to have a connector to the edge like this, then you would expand inwards, but not outwards. Now you might be thinking, why are we expanding the connectors out like this? Well, the reason why is because we want to take packers and place them on top of pellets like this to add another packer connection to them. If this wasn't expanded, there would be no connectors to this packer. So that's why we expand the connectors left and right like so. This ensures that every single pellet that you can place a packer on top of has a connector block adjacent to them. Next, you're going to do some Tetris with compactors and packers. You want a payload compactor, grab a packer. For this one, you want to make sure that your packers has the pins on top, on bottom, and one of the pin facing towards the compactor like so. And you want to surround the compactor on 3 sides with this. We'll grab our prefab tool. And what we'll do is, wherever you see this T-shaped pattern with the 3 pellets, you want to place this Tetris down on top of it. So look for the T-shape and place this down. Once there's nowhere else to put a T-shape, you'll start doing each pellets individually. Once again, you want to make sure you have pins on top and bottom, and the pin on the side points to where your compactor is going to be. You want to try your best to have packers share the same compactor so that they save on materials. So I'll have these two share a compactor in the middle. Now we'll go around to the remaining pellets and put packers on top of them. Now you'll notice we have some empty holes remaining. At the bottom of the hole is a payload packer, but the packer only connects to the pellets on the bottom and it doesn't connect up to anything. And the packers adjacent to it do not have any pins pointing towards the hole. What we'll use this space for is putting in gauge increasers. Now the basic 3D layer is complete and you just copy paste it to your desired height. And then once again on top we'll just connect everything up. Now I'll add some gauge increasers to reach 2000 millimeters. And now we have a significantly better gun. Way higher firepower and materials per firepower. But where is the increase in performance coming from? Well, if we take a look at the gun, what makes 3D Tetris 3D is if you look at one of these pellets in the middle, they have 6 connected packers. There's one on the bottom, there's one on top, and then there's the 4 packers that we had connected previously on the same layer as the pellet. If we compare that to our 2D Tetris, if we take any pellets, they're connected to the 4 packers adjacent to them, but they don't have any connections on top and any connection on the bottom. This is inferior to 3D Tetris because pellets are significantly more expensive than packers, and you want to maximize the amount of packers connected to every single pellet. There's also another important difference between our 3D Tetris versus what we had earlier. This one uses payload compactors, which increases the payload capacity of the shell. This is important for making your shells stronger and having more firepower overall. If you hover over the gun, it tells you how much is packed into each shell. For this one, 6,400 are packed into this shell. If we go into one of the previous gun, this one only packs 1,000 into the shell. And if you look at this one, it also only packs 1,000. One thing you should notice is that both this gun and this gun has the same amount packed into each shell, but this one has more pellet connections. This one has 624 pellets. This one only has 192 pellets. And what that does is it reduces your reload time. This one has a reload time of 11 seconds. This one has a reload time of about 7.5 seconds. So adding more shells reduces your reload time, but it doesn't make your shells any stronger. That's where these compactors come in. You need to have a good amount of these in order to have strong shells. A good metric to aim for is to get a reload time of about 30 seconds by adding more compactors. If you're just looking to build a decent gun, this would be a good place to stop, but there's ways that we can optimize this and make it even better. Now we're on to level 3, 3D CRAM Tetris with edge optimization. Now, the first few steps on level 3 are exactly the same as level 2, so I'm going to copy paste the gun over and then work from there. I've copied over the first 6 layers, and now we can start the edge optimization. The first thing I'll do is I'll turn the top layer into my connection layer. Instead of building a new one on top like this, that's kind of wasteful. So I'll just clear out everything except for the connectors. And now I'll just connect them together like this. Now we'll put one big line going down the center. And now we'll start filling in some of these pellets with packers on top of them so that none of them are getting wasted. I'm just doing the same thing here as previously. I'm adding in packers on top of the pellets and having them connect to compactors. And now I'll put the compactors in. Oh, I missed a couple pellets over here. Next, I'll copy the top layer and place it at the bottom so that these pellets on the bottom also get their own layer of packers on the bottom so that they're even more efficient. So we'll copy everything up one. We'll take the top slice and copy it down to the bottom. And then I'll add a barrel so that we can see the connections more easily. Now everything up to this point has been something you've seen before. Now I'll start by optimizing the top slice here. If you take a look at this packer, it has 2 connections. If we copy it up top, it connects up, down, and then to the right. So if we go into our small block view, it connects to this compactor to the right, and it connects to this pellet on the bottom. You can rotate this packer so that it also connects to the compactor to the left and have 3 connections total. Now there's an extra connection to the compactor to the left. And we'll just go through and repeat this for any others we find. This one, we can do this, so it connects to the left one as well. Same thing with this one, and this one. All of the ones near the center here only have 2 connections. Okay, the top layer should be optimized now. Let's take care of the bottom layer. This is the same as the top layer. You have these packers that only connect to 2, that when you rotate should connect to 3. So this one connects up and to the right, but if we rotate it, it will connect to the compactor to the left of it as well. And we'll just repeat this for the other ones we find. That should be all of them on the bottom. Now we want to check the sides to see if there's any improvements that we can make. This payload packer only connects to 2 shells. It connects to the one on the left and one on the right, but there's no connection on the 3rd pin. If we rotate this up or down, then it will end up with 3 connections, which is what I'm going to do here. Same thing for the ones below it. We can do the same thing on this side. Another improvement we can do is if we take this packer, which is facing this way, and we rotate it like this, we can actually fit another compactor here for an extra connection. And if we take this one and we rotate it like that, it will also connect to the new compactor. And now these have 3 attachments. We can do the same thing on top here. If we rotate this guy, and I'll just repeat this wherever I see it. Okay, I don't see anywhere else I can do that. I also see another place I can improve. If we take this, which is facing like this, and we rotate it, we can place a compactor here. And then if we take this guy, rotate it like this, we can also have it attached to the same compactor. We can't do the same thing for these packers above because they already have 3 connections. You can also do it on top here as well. Also missed a few earlier. You need to practice and get good at spotting the T-shapes where you can connect things while you're optimizing your cannon. It's important to get used to visualizing the T-shaped connections that packers make so you can quickly spot places where you can improve them. Now I'll go and check to see if I missed any spots. Now you might be looking at this and thinking, hey, why don't I rotate it and add another compactor to try and get 3 attachments? Well, the reason that doesn't work is if you remove this, it breaks the connection with the 2 packers next to it. So a quick way to see if an optimization is possible is just to remove the connector and see if any packers disconnect like this. In this case they do, so there's nothing we can do here. Now that I've gone through and optimized the edges of the cannon, we got to get that 2000 diameter gauge by adding some gauge increasers. There's not really a pretty way to do this. We are going to have to break some connections, but I want to use this empty space here for some gauge increasers. So I'm going to have to sacrifice this one packer just so I can add some gauge increasers. Still not enough, so I'll add it over here as well. And now if we compare the stats of our gun, we have 86.55 firepower, 327 materials per firepower. We gain about 10 more firepower and reduce the cost by about 20 or so materials per firepower. Now you might be looking at this and thinking, there's a lot of wasted space here on these diagonals. Which takes us to the next level of CRAM building. Now we're on level 4, the final level of CRAM building. 3D CRAM with edge optimization and offsets. Now there's one thing that the guns that we built previously all had in common, and that they all use the same offset. The offset is how you build your pellet layer. There's 4 different offsets that you can use. The first one is the diamond offset, which we've used previously. Then the inverted diamond. There's the 1 offset, and then there's the 2 offset. I'll cover each one now. The diamond offset is the one we've been using previously. An easy way to tell it's the diamond offset is when it has the connector in the very center of the turret like this, and it's surrounded by packers. And then you just repeat the pattern for the rest of the base, and this is what we've been building for the previous 3 guns. The next offset is known as the inverted diamond. The center of the inverted diamond offset has a pellet, unlike the diamond offset which has a connector in the middle. A bonus fact about the inverted diamond is that it's ideal for making multi-barrel crams. So crams with 2 or more barrels, you should be using the inverted diamond. The next offset is known as the 1 offset. It kind of looks like this. And this is the rest of the pattern once you fill it out. And the final offset is the 2 offset, which looks like this. And the pattern when filled out looks like this. Now I'll go into how these offsets get their names. What I have here is the packer and compactor Tetris you've been seeing earlier. If you place it directly in the center, you'll have the diamond offset, which is what we've been building previously. If you move where you start your Tetris over one block, then you'll have the one offset Tetris. It doesn't matter which direction you move it since the turret is symmetrical. Here I move it one block to the left, and now I have a one offset Tetris. You can then repeat the same Tetris pattern as before to fill out the rest of your turret. Now, if we go back to the diamond, if we move it one block in any direction, and then one block in another direction, for example, we go left one and down one, what you have is the two offset. This is known as the two offset, and you would start your pattern from here and fill out the rest of the space. Now we go back to the diamond. If you move two blocks in the same direction, then you'll end up with the inverted diamond. So I'm going to go up two blocks. And if you start your pattern here, you'll have the inverted diamond offset. And that's where these offsets get their names from. Now, does it really matter which offset you use? Well, yes, it makes a big difference actually. If you look at the diamond offset that we've been using, there's a bunch of empty space on each side that doesn't have any blocks going there. If we tried a different offset like the inverted diamond, you'll notice that there's less empty space. There's only one on each side as opposed to four of them. And then this is the one offset, and then this is the two offset. So depending on which offset you use, you can have completely different space utilization. Not only that, your edge optimization would be completely different as well, because the geometry of this offset is going to be different than the geometry of this offset over here. And the difference in geometry and optimization available makes a big difference on the final stats at the end. Now I'll take the gun we've been building previously and compare it to these other ones that are built using different offsets so we can see just how big of a difference it can make. This one is 86 firepower. This one is 92. This one is 86.5. This one is about 86. And I'll put on screen the stats of all four cannons using different offsets so you can see the difference. Unfortunately, there's not really a way to tell which offset is going to be the best offset for a particular gun. The only way to really find out is to try every single one and see which one ends up the best. But I do notice a couple of things about the offsets though. The diamond and the inverse diamond tend to work best on the larger guns, like the 11x11 and larger. And the one offset and the two offset, they tend to work better on the smaller guns, like 5x5 or 3x3. One offset or two offset can make a pretty big difference in performance. I've already tried all four different offsets, so I can just cheat and tell you that the inverted diamond is the best offset to use for this gun. And I'll be building a new gun from scratch using the inverted diamond offset so you can see all the different optimizations that can be done compared to the diamond offset. We'll start with a turret base. And then this is my prefab for the Packer Tetris. We want to make sure it's the inverted diamond, so I'll start in the center and then move 2 blocks away to start the inverted diamond pattern. And then we'll fill out the rest of the Tetris. Now I'll add in the pellets. And now I'll do the 3D layer. I'll be going a little bit fast on the things that you've seen before. I don't want to waste your time. This is just my little T-shaped compactor packer Tetris. I'll fill in all the T's. And now I'll do each pellets individually. Here I'll have these three packers share the same compactor. And now I'll fill in gauge increasers on the empty space. Now I'll copy paste our two slices. And now I'll turn the top layer into my connection layer. I remove everything but the connectors so I can add them back in after connecting them. Now I'll add the packers on top of the pellets and connect them to compactors. And then we'll put some gauge increasers here. And now I'll just copy this to the bottom. I'm going a bit fast because everything up till now you've already seen me do before. And I want to get to the interesting part where I start the edge optimization. Now we'll add a firing piece so we can see what pieces are connected. And now I'll start with the edge optimization. Like before, I'll start by optimizing the top slice. So this packer here connects down and to the right. If we rotate it, we can also add a third connection to the left. Like this. Same thing with this guy. If we rotate it, we can have it connect to a packer in the middle like this. These packers in the middle already have 3 attachments, so they're good. The bottom one, we can do the same thing as the top one. Rotate, so we can add a third connection. And now I'm going to go and do it on the other side. And do it on top as well. Oh, make sure this is pointed down so that it connects to the pellet on the bottom. Okay, let's look for anywhere else we can optimize. I can optimize these packers on top by having them rotated to connect to the right, bottom, and the left, like this. If we go into our small view, we can see a pellet on the bottom that we can connect to. So I'll go through and swap these out, and then I'll change this gauge increaser into a compactor. We'll do the same on the other side. and change this gauge increaser as well. This packer, we can rotate it so it connects to the compactor to the left, as well as the pellet on the bottom and the compactor to the right of it. And then we'll do it over here. Fortunately, the inverted diamond is symmetrical, so what you do to one side, you'll go and do on the other side. Alright, I think I got all the pellets on the top slice optimized. Now we'll start optimizing the bottom slice. This one we can rotate to connect left, right, and then up. And we'll switch this to a compactor. Same thing here. And here. And then we'll repeat on the other side. This packer we can rotate to connect to the pellet to the right of it as well. And then we'll do the same on this side. Alright, now everything on the bottom should be more or less optimized. I'm going to start looking at the sides and seeing what optimizations I can do. I see another optimization that we can do here. These packers here only connect to the pellet to the right, when I can rotate them and also have them connect to the compactor on top and below them as well. And that adds 2 new attachments to them. Like this. And then we can repeat over here. And since it's symmetrical, I know I'm going to have to do it on this side as well. We don't have compactors on this side, so I'll add them in. And then we'll rotate this to connect to all 3. Now I'm just looking to see any others I can do. There's another optimization we can do over here. This one will need you to get a little bit creative to see. So we have these packers to the left and to the right. They connect to these CRAM connectors next to them. And without the connectors, they won't attach to the rest of the gun. Currently, each one uses a single connector to connect them to the rest of the gun like this. You can be more efficient by putting the connector down the middle so that each connector connects both packers at the same time. We're going to have to sacrifice one of these packers, but the space that we gain from removing these side connectors will more than make up for it. Alright, so right now they're all disconnected, and we'll connect them down the middle. Replace this one as well. And now what that lets us do is we can rotate this to connect to 2 extra compactors. So right now this is only connected to the pellet on the right, but if we rotate it like this, we can connect it to the right, and then up, and then down as well. And then we do the same thing on the opposite side. And then we'll put our compactors above and below the packers. I'm just checking if I can rotate this to get an extra connection, but I can't because it won't make a T-shape. Alright, since this is symmetrical, we're going to have to do the same thing on the opposite side over here. We'll put a line of connector going down the middle. And that frees up all these connectors to become compactors. And now we rotate the packers to connect to the extra compactors we added. Here we can optimize this setup a little bit more. So we have packers that only connect to the pellet to the right of them. But if we rotate it like this, we can make a T shape and have it connect to the right, and then above and below with compactors. And then we'll get rid of the gauge increasers and replace them with compactors. Alright, let me check if this is connected. Okay, this one we can rotate and have it connect to the compactor to the left, like this. And let me check the one on the bottom here. We can rotate this one and have it connect to the one on the left as well. Alright, since we know this is symmetrical, we're going to have to do the same thing over here. Rotate this, so it connects left and then up and down. Get rid of the gauge increasers and put compactors where they were. And then we have to remember to do the one on top and the one on the bottom. And now we'll check the other side to see if we have to do the same thing. Over here, it's a little bit interesting. We have these connectors, but I don't think they're actually needed, so we'll get rid of them. And these packers don't need the connectors at all, so we can rotate these so they connect to the pellet on the left and the compactor on the top and bottom. And then we'll put compactors next to them. Now we'll do the same thing over here, get rid of the unneeded connectors, and then add in compactors, and then rotate our packers. Now these packers are not properly rotated. They have compactors on top, on the bottom, and to the left of them. But the pins aren't facing the right way. So we rotate them like this, they'll have 3 attachments. And then we'll check the other side to see if we need to do it. We do, so we have to rotate the packer to connect up, down, and to the right. Okay, let's check if we need to do something like that here. Here we have another case where we have extra connectors. We can replace them with compactors and then rotate our packers to face them. So we can rotate them like this to connect to the shell and the compactors above and below. And then we can do the same thing on this side. Alright, I see another optimization we can do. If we get rid of this compactor, we can add a CRAM connector and then add a packer below that will connect to these 3 pellets. If we compare this to what we had before, we had a single payload compactor that's feeding into these 2 packers. And if we do it like this, these 3 pellets will have an extra packer. And pellets are more important to optimize than compactors. Now we do the same thing on the bottom. And then I'll check the other side to see if we can do it. I'm looking to see if there's anything else I can optimize. I couldn't find anywhere else to optimize, so now we have to add in gauge increasers so we get the 2000 diameter. Now you're going to have to remove blocks in order to fit in the gauge increasers. There's not really any empty space remaining that we can reasonably fill these in. So we'll look for where we can make the least impact by replacing the block with a gauge increaser. If you look at this compactor, it's connected to the packer to the right and below it. So if we replace this, it would impact two packers. If you compare it to this one, which only connects to the packer below it, swapping this one out with a gauge increaser would hurt less than if we swapped this one out. I'm going to look for more places with only a single connected packer, like this one on the bottom, this one here, this one here, and here. And now we need two more. Can swap out this and this, and now we're at 2000 diameter. Now if we look at the stats, if we compare this to the previous CRAM without the offset optimization, we can see some pretty big improvements. We gained 5 more firepower, reduced materials per firepower by 20, and decreased volume per firepower by 0.5. So offset optimization can be really time consuming. You have to test out different offsets and then try your best to optimize each one and then see which one of them performs the best. I don't really recommend this step unless you're really trying to min-max whatever CRAM cannon you're working on. I think stopping at the previous level with the edge optimization is enough for most people. And if you're just trying to build a gun quickly, then I think doing the basic 3D CRAM with no optimization is more than good enough. I think you should never build 2D CRAMs because they have awful stats, and it honestly isn't that hard to build 3D CRAMs, especially if you skip the whole edge optimization step. Here's a table with the stats of all the guns we've looked at in this video. I hope you found this video useful. Leave a comment if you have any questions or suggestions for my next video. Thanks for watching.